So here we see my LTSPICE circuit for this low voltage op-amp. There are some important things to look at. One is the 0.1 microfarad capacitor that prevents noise from getting on this circuit here, which is unnecessary for LTSPICE. The other is the 820K resistor being used in the feedback there, which is the load on my output. If that resistance gets lower in the physical circuit, it doesn't work properly. It gets crossover distortion. However, it does work on LTSPICE, so you have to be careful about the LTSPICE. The model we have for the TL-C27L2 doesn't incorporate crossover distortion to keep it something that will run fast. I do have the 10 megohm dividers that I'm using to get 2.5 volts, and the 0.1 microfarad capacitor that I'm using to couple my AC signal, which is actually centered around 0. And you'll notice I've changed my space to 10 and my mark to 10K. That's because this is not a very fast op-amp, and you don't see much if you go to higher frequencies. I have 0.15 or 150 millivolts here because this sets the amplitude, not the peak-to-peak value of the output of this modulator. So to match my measurements, so I run my simulation, I get this kind of display, and here I've set up the display by tapping like this to get 5 volts as the top and 0 volts as the bottom and 1 volt as a tick, and this is exactly like what it is on my screen here. So these look quite similar.